Assalamualaikum and hello. In this video, we are going to learn how to write the equilibrium expression in terms of partial pressure for homogeneous equilibria. So let's get on with it. I got the general expression here where my left side is going to be the reactance and my right side is going to be my product. So how you want to write the equilibrium expression in terms of partial pressure, you have to write the symbol Kp and make sure K is the capital letter and P is for the partial pressure equals to, my top one is going to be the partial pressure for product, so it's going to be P in the bracket lower subscript C, which is referring to my product C, to the power of coefficient C here, and times with partial pressure for D, my product D, to the power of the coefficient D. So this is for the top one, my products, and the next one I got my reactance, which is partial pressure for A to the power of A, coefficient A, times with partial pressure of B to the power of coefficient B. So make sure you write the correct one as equation given, but please check first whether the equation is balanced or not. And as you see here, A, B, C, D are the stoichiometric coefficients, and Kp is going to be the equilibrium constant in terms of partial pressure, and P, the big capital letter P, is referring to the partial pressure of gas in ATM. Let's do a few examples here how you want to write the expression for Kp. Please make sure for Kp, your species must be in gas phase only. So I repeat, your species must be in gas phase only. If you got in liquid, if you got in solid, if you got in aqueous, all of them are not acceptable to write as Kp. So for this one, how you want to write the Kp? I got N2O4 in gas, reversible with 2NO2 in gas. So my product first in bracket bulat P, capital P, and then kecil di bawah NO2, close the bracket to the power of 2 over bracket P, capital P, for N2O4, close the bracket to the power of 1. So this is how you want to write the Kp expression for this example. And make sure awak tak guna square bracket in this case, because square bracket is just for concentration only. So in this case, you use bracket yang biasa saja, the half circle one. Now we go to the next example. I got this expression, and please make sure the equation is balanced and you got all of the species in gas phase. Okay, please remember about this. Only for Kp. And how you want to write it down, you are going to write based on your product first. So your product, you got SO3, so P SO3 to the power of 2 based on its coefficient over P for SO2 to the power of 2 from here, and you got times with P for oxygen to the power of 1. So this is the expression for the second example. As you see here, all of them are in the same phase. The next example, I got the reversible reaction between N2 gas plus 3H2 gas reversible with 2NH3 gas. So make sure the equation is balanced and all species are in the gas phase. So when you want to write the Kp expression, the top one for your product, so P in bracket for NH3 to the power of 2 over P in bracket for nitrogen times with P for hydrogen in bracket to the power of 3. and make sure you know how to balance the equation. And one last thing that you have to understand, that you have to take note that equilibrium constant expression Kc and Kp got another name, which is equilibrium law expression. So sometimes they will use another term, but both terms are referring to the same thing. Please alert about this. So to conclude about your lesson for equilibrium constant expression in terms of Kc and Kp for homogeneous equilibria, for example, I got this general one. You know how to write the Kc and you know how to write the Kp. And make sure for Kc, K is referring to equilibrium constant, C is referring to concentration, P is referring to partial pressure, and for Kc, your species must be in square bracket. For Kp, your species must be in the normal bracket with capital P, lower form your species. So maknanya size tu awak kena bezakan lah, jangan sama size dengan P dekat atas ni. Okay, so you know that these are the term that you have to remember. And I hope you know how to write the equilibrium constant expression by now. Next one, you have to take note a few basic things about Kc and Kp. The first one, equilibrium constant Kc and Kp is dimensionless. It means that you have no unit. There is a value for them, but no unit. For example, I got this equation and I got the value for Kc is 1.67 and Kp is 4.07 exponent -2, and both Kc and Kp are at temperature 500 Kelvin. So this is how you want to write the value for Kc and Kp, and as you see here, there is no units for them. That's the first thing you have to take note. The second one, when you quoting the value of Kp and Kc, you have to take note the temperature must be specified beside the value of Kc and Kp. And of course, when you write the equation, you have to put the phase for all species in your equation. For example, I got PCl3, I put the phase here gas. And same goes for Cl2 and PCl5. And after that, I indicate the temperature for Kc and Kp beside it. So make sure you follow this second requirement in writing the Kc and Kp expression. So I leave it to you, exercise try this 3.0, and make sure you know how to write the Kc and Kp. Try to do this exercise. Don't forget to balance the equation first. And I also leave it to you, try this 4.0 and try this 5.0. Both of them got the final answer, including with try this 6.0 with its final answer. I wish you all the best and see you in the next video. Bye!